Okay, friends, good evening. So today we will enjoy very nice numericals. Now, just a beginning. I wish all of you just have a look at this. I think you can all read this. Hello? Huh?
Yes, sir.
Just recollect what are all these equations and their physical significance. Okay? So,
Yes, sir.
that should refresh us from whatever we did in yesterday's class, right? Okay, and now we should start drawing the free body diagrams like this. Okay, so you see here summation of all the forces. You will keep that vector at the center of mass, and the vector magnitude will be m into AC. And then the torque about some point, you will write it like this. So as I told you yesterday, we'll have to say the body because of this net force, because this net force is shown here, but this net force is what? It is the summation or the vectorial addition of many forces acting at different points. So these forces, the net force, the forces are distributed, then it will give rise to this vector. Okay, which vector? IC into alpha.
Yes.
And this net vector, when you look at it from this point through this vector RC bar, then you will get this term. Okay, so this equation, then of course summation FA bar is equal to AC, and AC, as you can see here, is the vectorial sum of the tangential component plus the radial component, AC itself. Okay, so if you stand at the mass center of the object where many forces are acting, then you will, if you see, you will see the vector AC bar, but you should also know that this vector AC bar has got two components. Okay, if you stand at the center of the object. Okay, and if you are able to see the angular acceleration of that, then you will have to get the moment of inertia about the center and look at it like this. And if you are going to look at it from some other point P, then you will have to get the moment of inertia like this. And again, if you look at the center of the mass AC and acceleration there with respect to some point P, then you will get the angular acceleration times this plus this. Okay, if you see all these equations, I hope you are able to visualize them, convert them into physical quantity, and then go about it. Okay, friends. See, I am showing all these things to you because this is how you have to prepare your synopsis, right? Just before the examination. So you should be able to write all these equations on your own, and these diagrams also on your own. Just a refresher. Okay, just like that, the athletes before they start the race, they will do like this, and then do something like this. They will jog there, and then they will start doing. You should also do. Thank God you did that point. Right. So you should also do this before you go to the examination. Okay, and these are going to be your free body diagrams.
Yes.
Now, Aram se solve this problem, and some of you might have solved it, but anyway, now again resolve it with a new figure. Okay, yes, please, with proper diagrams, I want you to draw the right diagrams and then approach this problem. So here, a block of mass small m is suspended with the help of a light cord. Light cord, why that word light?
Mass is negligible.
The mass of the string.
Weight vector of the...
No, mass of the string is negligible.
Yes. Yes.
Over a cylindrical pulley of mass m and radius r. So cylindrical, that means they have told what is the shape of it. Okay, of mass m and radius r, as shown. The system is released from rest. Find the angular acceleration of the pulley and the acceleration of the block. Now, earlier we have used this and we have solved this problem using this diagram somewhere. But only thing is, we had assumed this pulley to be massless.
Yes.
Then, what is the acceleration of this string at that time if this pulley is massless?
mg minus tension by total mass.
If this is massless,
What question? Which?
if this pulley is massless, this m, capital M is equal to 0, then what is the acceleration of the string? G.
Yes, sir.
It is G only, correct? Because see, now mg is the force that is acting on the system.
Yes, sir.
Mg is the force that is acting on the system. Okay, and what is that inertia of this which is opposing this? When they say the capital M is 0, the only other inertial material is small m.
Yes.
So mg divided by the inertial mass here gives you the acceleration, and that is g. Precisely we have done this problem. Okay?
Yes.
Or else, we had used this pulley and we had taken the string from this side, m1, m2. We have solved problems like that. But in all those numericals, this pulley was massless.
Yes.
Okay? Now that it is massy. Okay? So therefore, shall I say that the acceleration here now, shall I say the acceleration here now is mg divided by small m plus capital M?
No. Yeah.
What, Mr. Dimant? So you are not alert. See, you are taking some time to get into the class. Arun, if now the acceleration here is mg divided by small m plus capital M. Are we done? So, see, that is possible if it was like this. Say this is the table, this is the pulley, I have got a mass here, okay, capital M, and there is a string that is coming down here, and there is a small mass M here, okay. Now, and if I say the friction here is 0, then what is the acceleration of this point? Acceleration of this point will be mg divided by m plus m.
Yes.
Correct, no?
Yes.
Hello? Hey, everybody participate.
No, sir. Yes. Yes, sir.
Only those students who are participating are participating. But now in this case, so instead of that block, we have got a disc. We have got this disc. Instead of this, we have got this disc of same mass. Okay. Only thing is it is coming. Correct, no? So therefore, the acceleration of this is this. So this acceleration also must be same. Correct, no?
No, sir.
Why?
Sir,
Why?
because the whole of the pulley will not be moved with that acceleration. Yes.
Whole of the pulley is not moving. So half of the pulley is moving.
Sir, different parts, different accelerations. Different parts of the pulley will have different accelerations.
Is that the way you are going to capture this problem?
No, sir. Like that we cannot do, sir. But
Tell me. So you are sure this acceleration for this will not be this. But
No.
then why it will not be the same? You said you have solved this problem in the college.
yes.
What is that you have learned from this problem?
So there will be another reaction force at the police which will prevent it from.
Okay, what? This hello, gentlemen. You are talking about this reaction force. Correct?
Yes, sir.
And this tension is here. Yes, this tension T will be equal to this tension. See, this tension plus this tension T. This tension T is acting down, and on this pulley, this reaction R is active, isn't it? And these two forces are equal and opposite, and therefore this pulley will not translate.
Yes,
Yes, sir.
Now, why this acceleration cannot be applied here? What is the difference? Here there is mass m, here there is mass m. Here there is mass m, here there is mass m. Here there is mg, here also there is mg. Then what is the problem?
Sir, here the pulley will not translate. There that block mass and capillary will translate.
Okay, fine. Continue.
So in that case, we cannot.
So then it was common acceleration, sir. Like both masses produce the same acceleration. Here we cannot do it.
So all that I want, all that I want.
Inertia is different.
The inertias are different. The inertias are different. So now, even though the mass is same, you have to consider the inertia for rotation. See,
Yes,
here
yes,
you will
yeah.
consider inertia of rotation,
Momentum.
and here you will
Yes.
consider inertia of translation.
Yes, sir.
Yes, sir.
That makes the basic difference.
Yes, sir.
Yes, sir.
See, you have to learn from the problem like this, gentlemen. Right? Anyways, it's okay. No, I'm just putting it like this because all of you said, sir, we have solved this problem. But then, yes, you might have solved, you might have got the answer. But that's not your goal. Your goal is not the answer. Your goal is what is that physics that you learn from this problem.
Yes.
Understand? So this is a wonderful saying, when you were all kids, when we were all kids, we were standing at the footboys gazing at the sky. Okay? And then your teacher is showing your hand and saying, look at the moon. So you should look at the moon. The finger is pointing. But if you look at the finger of the teacher, then you will not see the moon. Isn't it? So same thing here. Yeah, anyways. So therefore now, the main difference is that, the inertia of this system is different from the inertia of this system.
Yes, sir.
And the second thing is, here you see, this force mg here, okay, was causing translation of this and also this. But here, this force mg will cause translation of this and rotation of this.
Rotation of yes.
So therefore,
Yes.
you remember the definition of torque? Torque of a force. Torque of a force on a body about a point. That concept will come into picture. Now this very force tension is the source of the torque on this body about this point.
Yes.
About this point. Okay, so therefore you have to consider the torque of this on this, and due to this torque there will be angular acceleration of this.
Angular acceleration.
Yes, sir.
And due to this force there will be translatory acceleration of this.
Yes, sir.
Now this angular acceleration and this linear acceleration, they will get related. They will get related. Okay, what is that relation? Here you see the angular acceleration alpha into the radius r will be equal to the translatory acceleration alpha.
Yes.
A.
Yes, sir.
So that's how it will get related. Alright, friends?
Yes.
And this translatory acceleration alpha, okay, what is this going to be? Torque divided by the moment of inertia about C. About C. And what is the torque that is going to act on this? The torque will be this force. This force into this distance.
Yes, sir.
So the torque will be the tension, the torque will be the tension into R.
Yes, sir.
This radius is R. Okay. And what will be MC? They told it is a cylinder. So it is M into capital M into R square. So this will be this. Okay. And so now you will get tension T here. This will be the tension. Now, what is this acceleration A of this? This acceleration A of this will be mg minus tension divided by M.
Yes, sir.
Yes.
Yakba?
Yes.
Yes, yes.
So mg minus T by M. This will be the this of this. And here from this equation you can pull out the tension T value and put it here. And then if you pull the T out from here, put it, you will get this in terms of alpha. So you will be able to relate A and alpha from this. Is that clear, friends?
Yes, sir.
Yes, sir.
That's fine. So you see, anyways, it's, don't worry. It is not a very big thing. Then Brahma Vidya alla. It is just that you have to now start thinking about rotation, translation, and a combination of this, because we are not used to. See, this transition, what is going to happen to you in the next few classes is something different. Yeah, is a transition. Why? Because from 8th standard, we have been only calculating acceleration, velocity of translated motion.
Yes, sir.
Okay, we have not encountered the rotational motion and really working with things like this. We have calculated, oh, alpha, this is it, and all. Now, in reality, I'm just making something like this, and therefore, our mindset has to get adjusted to this new reality. It takes time, right? Just like how you see, if you apply force to a body, see, if you want the velocity of a body to increase from 0 to some, say, 10 meters per second, it will not happen instantaneously. However, it will take some time. So for all of us to develop the mindset for it, it's going to take. But that's what I said. You should be cautious, and you should start using the right concepts. Okay. So difference between this body and this body is this is translating, this is rotating. So I consider the translatory inertia. I will consider the rotational inertia. And this force, yes, is going to cause the torque, and the inertia is I. All right. Did you get it, friends? All of you? Okay, fine. Don't worry. Now,
Yes,
very
sir.
nicely solve this problem. Very sweetly, with right diagrams and all, you solve and get the answer. Do it, aram. Find the angular acceleration of the pulley and the acceleration of the block. They are asking you alpha and A.
Yes, sir.
And remember, the terms
Yes, sir.
the term that should come there is small m, and capital R. And of course, you can use G. G will also come.
Yes, sir.
आराम से, all of you. प्यार से, आराम से. Start putting the right diagrams. So they have asked us what is alpha and what is E. We have to find out.
Sir, capital
Oh, thank you. Oh,
Yes.
Yes, sir.
Yes, sir.
Yes, sir.
yes, all of you got. But
Yes, sir.
see, I have not completed the problem there. I should get a A in terms of the quantity that I told you. The quantity
Yes,
is.
sir, yes.
Put D by capital M, sir.
Put the.
We'll get A as 2T by capital M, sir.
Yes, sir.
Sir, 2mg by 2m plus capital.
Hey, ma, you
E
understand?
equals to alpha
Yeah.
2 plus by m.
I should get the answer only in terms of this quantities. That's what I'm trying to tell you.
Yes, sir.
Do it. You finish it. You tell me. Done. Okay.
M by M
Okay.
plus capital M by 2.
So this small a is equal to what?
Yes.
2mg by capital M plus
Hey, 2.
2mg.
See here when you say m, you tell properly.
Small
To tell 2 small m g
capital M plus
divided by
capital M plus 2
Plus?
Capital M plus twice
small.
small
2 small m.
Small M, yes, sir.
Huh.
Yes.
Okay, and alpha is equal to?
that into R.
Multiply this by R.
Okay, simply
That
here
divide by
Divide by
R.
R.
Divide by
Divide by
R.
R.
2mg by m plus 2m doing
Yes,
Huh.
yes, sir.
Now, did you all get this answer?
Yes, sir.
Yes, sir.
Now, did you cross check whether this answer is correct? Anybody?
Yes, sir. Yes, sir.
Yes, sir.
How did you cross check?
Sir, I'll put capital M as 0, sir.
Good.
My solution get as G, sir.
Yes, sir.
Understood?
Yes.
This is how you should solve the problem. Because see, you have gone through many steps. Finally, yes, you have got the answer. But what is important is, sometimes you could have missed out here and there few variables, and then, you should not go for. So therefore, a final check is necessary. So that's right. I started this problem by saying, if this capital M is equal to 0, then what is the acceleration A? And then we started with our journey with say A is equal to G. Right? So we have an idea how things are going to look. And then we went about writing all these equations. And finally, when we get this answer, we have to verify. because you see, you have to pretty sure that your answer is right. This is called as check and balance. So you solve it by some means, fine. Now use a different concept and resolve this problem, or at least counter check whether it is right. Counter checking means checking like this. Understood? It's not like checking like again, oh, whether my steps are correct. Everybody got it, friends?
Yes.
So here
Yes,
you
sir.
see, friends, you must learn. Learn. Learning should be your target. Okay, getting answers. You know, it should be an obvious thing that will happen. It should be a consequence of the process of learning. Okay, so you should not lose focus on it. Well done. Shall we proceed, students?
Yes.
Yes, Sunday,
Yes.
friends.
Yes, sir.
Yes, sir.
ಅನುಗುಳು
Yes, sir.
ನೀವು ಸಿಗ್ಬೇಕಾಗಿತ್ತು ನಮ್ಗೆ ಎದುರು ಫಿಸಿಕಲಿ ಮಾಡ್ತಿದ್ದೆ ಎಲ್ಲಾದ್ರು
Sir, it was stuck, sir.
ಸ್ಟಕ್ ಓಕೆ